Awesome. Yeah, thank you, John, for that. I'm really excited to be here. I'm excited to talk to you about what is this whole DevEx and platform engineering I keep hearing about. Before we jump into it too far, if you're interested in getting in touch with me after this, or I'm unable to answer a question, or you're watching this as a recording, please feel free to reach out to me. You can reach out to me on LinkedIn, or you can reach out to me over email or via GitHub. Uh, just note that I'm a field CTO. I'm not the CTO, so I get some rather strange emails and messages sometimes because people think I'm the CTO, but it's all good. Now, I come from a development background. In fact, one of my very first jobs was converting classic ASP pages over to ASP.NET web applications. So I have a .NET background, and I started in the very early days of .NET. And so what's interesting about these two topics, platform engineering and developer experience, is we've been doing this for quite some time, but we haven't really been putting a name to it. So I'll walk through what this is and what these processes are and how they are slightly different and how we've kind of focused them down. But just note that this does start for 20 years ago, really, when you start thinking about it. And I really wanted to design a session for people who have kind of a minimal knowledge of what is this DevEx and this platform engineering and how does that impact me. So if you're doing platform engineering today and that's all you do all day, every day, or you're say the vice president of DevEx and you're watching this, I mean, you can continue to watch. I hope you continue to watch, but this is much more of a high level as opposed to down into the nitty gritty. So in terms of an agenda for today, first, we'll start off talking a little bit about what is this whole developer experience that everyone has been talking about. And then we'll move on to platform engineering because really the two are interlinked, but they're not the exact same thing. Then we're going to move on to what is the difference between a paved path and a golden path. Then I'm going to talk, why are we doing this now? Why is these suddenly becoming such a very hot button topic? Why are companies devoting these resources to it? And if you do decide to focus in on developer experience, how can you avoid the pitfalls? Then I'll talk a little bit about measuring success and I'll use some real world examples. And then we'll wrap it up with some resources. So let's first start off with an introduction to developer experience or to DevEx. And I like to start with a story. So Sarah is on our cloud platform team. And a couple of months ago, she was tasked with performing any change and just a change that's out there. And due to some testing practices, due to some internal, processes or whatever the case may be, she didn't get something checked in for multiple days. You can see on the screenshot that she started on April 4th and she wasn't unable to get everything pushed up and ready into main until April 9th. And so that really is the crux of what DevEx is when you have to do a lot of what's known as yak shaving. And yak shaving really is that those just series of tasks that you have to do just to move the project forward. Now, if you come from a developer or operations or really any sort of IT background, I guarantee you have shaved your fair share of yaks. You may not have known that's what you're doing, but it's just those little things that you have to do that just add to the annoyances throughout the day. Um, so that's really what developer experience is focused in on. And honestly, we can tell quite a bit about a company and their focus on developer experience based on their onboarding experience. And so what we refer to that is like if you hire someone brand new to the company, what is their experience like with getting into the code base? But it could also be someone who's just new to the project itself. They came over from another team, they're getting reassigned, whatever the case may be. How long does it take them to get onboarded? And then we can also look at how hard is it to get into production? How many yaks do you have to shave in order to just do a production deployment? I worked at a particular company, I won't name names, where we had to fill out a very extensive Word document just to get into test. And then we had to fill out another document to move up to staging, and then another one to move up to production. So that was a lot of yaks that we had to shave just to move between environments. And so that it took a while to get up to production. And so if we could get something up into production in under a week, that was like a monumental effort. Now, GitHub in their blog, developer experience, what it is it and why you should care, they have put together a bit more of a formal definition, which is the systems, technologies, processes, and culture that influence the effectiveness of software development. It's a really nice, succinct way of explaining developer experience. But I look at developer experience of it really gives a name to something that if you're a senior person, if you're a senior engineer, if you're an architect, you're responsible for helping to onboard people. It's something that you've been partially focused on for years and years and years. And, again, we haven't called it DevEx for forever and ever, but really, again, if you're a senior person, this is something you've been focused on for years. Now, when I worked at when I worked at DTN back in 2017, we were undergoing a digital transformation where we're going to be changing around our tech stack. And uh, my manager came to me and said, I know you're really pushing for this and you're kind of the architect behind all of this. We need to make sure that everyone's developer machine is ready to go. That means we have to install all the new frameworks, all the new tools, all the new IDEs, whatever the case may be. And the concern was is having them come into a room and do all this extra work and monitoring them and making sure they're clicking on the right things. And we said, maybe we can script this out. Maybe we can automate the developer machine setup by doing this. And I took some of those lessons and I wrote a blog post in 2019. So again, we've been talking about this for years and years. And there's a people impact to focusing in on DevEx. We can see where we can improve the productivity of a developer, how much of an impact on all the changes that they can make, as well as how satisfied they are with their job by making it easy to get into production where you don't have to shave all these yaks endlessly. And we can actually measure developer experience as well. So if you're onboarding someone, one of the things that Microsoft has talked about is the F5 contract. And that makes sense because Microsoft, being a .NET, you know, primary maintainer, they're focused in on F5, which what that means is how long does it take to download the latest version of source control? Not the latest version of source control, the latest source from source control onto the developer's machine, install all the necessary tools, and then be able to actually run the application. Is it 10 minutes? Is it several hours? It could be any number of those different things. Again, back when I worked at DTN, they used Oracle as the primary database, and this was 13 years ago. So it's been a while, so they might have changed. But if you've ever used .NET with Oracle, you know that that's not really a joyous occasion. And there's this, I think it's this client that you have to install on your Windows machine. And it took me well north of a day, if not 2 or 3 days, to finally get the thing connected and working as appropriate. And that was just due to, the tools and the frameworks that we had to use and just all this audit manual stuff that we had to do. So the F5 contract, it took quite a while before I actually had a version of the code running. And then once you have something running, how long does it take to commit for the very first time and get that change pushed up to production? And then when we focus in on future work, we're really talking more along the DORA metrics. How long does it take to make changes and get them into production? How often are you deploying to production? And so on and so forth. But then we can also ask the developers by sending them out a net promoter score. Internally, we call it the engineering NPS, where we're asking R&D, how satisfied are you with your job? What could we do better? Any number of those different things. Now, working at Octopus Deploy, naturally, from our company's point of view and the tools that we provide, we're more focused in on the DORA metrics and improving something along those lines. And I hope you like Simpsons gifs because in quotes, because I'm actually going to be using that quite a bit in this particular presentation. But this is something that we're focused in on because this is the impact that we can help make. Now, I'm not saying that, you shouldn't focus on the F5 contract or the time to first commit. I'm just saying that's just something that as a company, that's not something we can have a really big impact on because that's not where we live in the software delivery pipeline. And when you have a great developer experience, the appropriate DORA metrics go down or they go up depending on what you're trying to do. It makes it super easy to get changes into production so you don't have a high lead time and you feel comfortable deploying more frequently and you don't have the failures. And even if a failure does occur, you can recover really quickly. But when you have to shave a ton of yaks, you end up in a situation where they're going in the opposite direction. So DORA metrics are not the end all be all, and we'll actually get into that in terms of how do you measure success. But at the same time, they're a good indicator. They're a good smell test. They're like, hey, this is clearly showing something is not working correctly. But ultimately, DevEx is really the responsibility of multiple teams and people. It's not just the responsibility of a singular team. So internally at Octopus Deploy, our R&D leadership team, and we're talking our VP of engineering, our VP of product, all of our directors, they're focused in on the developer experience. And they're empowering teams to improve the developer experience, um, to make sure that we have a really great overall culture. And individual teams are also responsible for improving the developer experience. Going back to Sarah, the cloud platform team, I pulled that off of one of the presentations that they recently gave. And they were talking about how they can improve, they wanted to improve the developer experience so that didn't happen to the next Sarah, so to speak. And so they were empowered to take the time to improve that because that clearly was a problem. But we also have teams that are focused on making Octopus Deploy simpler and safer too, as well, to make all those changes. And so we have, say, a team that's focused in on, hey, how can we make it easier to make, say, database changes? So one of the big things that they're focused in on is moving from our own internally created ORM over to Entity Framework. We also have a team that's constantly focused on improving the build and delivery of Octopus Deploy. Now, I do want to point out that this might be unique to Octopus as opposed to, say, other companies, because the tool Octopus Deploy is a big monolith where we have a lot of teams making changes to it. And so there has to be these foundational teams. There has to be these centralized teams that are focused on build and delivery, because we have a single product really for a vast majority of our R&D folks. So you might have something different. You might have a different organizational structure on how you control that. But I just wanted to point out how we handle it internally. But I also want to point out that developer experience is not just about automation. Some of it can be solved by better documentation, or it could be solved by just tweaking a few processes here and there. So again, going back to what we do internally at Octopus Deploy, when someone gets started, they are given access to the Octopus Deploy GitHub repo. And in there, there's a lot of documentation on what you need to do to get started and all the steps you have to do. And then again, we're focused in on the F5 contract. So we walk you through, okay, what does it take to run Octopus Deploy locally? And we'll provide you a step-by-step guide on how to do something like that. As you can see, we're using things like Docker Compose to quickly spin up a SQL server, a Seek server, and the Octopus server itself with the web portal. Okay, so now that we have a better understanding around developer experience, let's talk a little bit about platform engineering and where does that fit into this whole ecosystem. So platform engineering is really an iteration of DevOps because DevOps has been really successful. Almost everyone universally agrees that breaking down silos, talking with other people in other roles, it's always a good thing. You know, just working alone and throwing things over the wall, that's never a great thing. But what we've seen is that there have really been three stages of DevOps. There's this divided stage. And if you've read the Phoenix Project or the Unicorn Project, they spend a really long time talking about the divided stage. And they throw up all these crazy different scenarios. And then people come together and they agree, hey, we need to solve this. And it's typically a Tiger team or a rapid response team or just a group of people that get together, and maybe they bring in a few other teams to start aligning and solving these particular goals. And then it comes time to take those lessons and basically push that out to all of the other engineering teams or the development teams. And this is where you can remove the metaphorical walls and allow everyone the benefits of DevOps. But all too often, what we've seen is that companies will typically get stuck between that aligned and combined stage of how can we make this big jump? Because it is a pretty big jump. It's a huge chasm to cross at times. And if you can get to the point where you are in this combined stage where you can build it, where you build it, you run it, where you've empowered the team so much that they feel confident and they're given the processes and tools that they can host the applications that they built because they have all the necessary expertise, that's a great thing. And so what platform engineering does is it helps you get the benefits of DevOps at scale. It's what enables you to do that. And the way that they do this is by building self-service internal developer platforms, or IDPs, to put together the processes to help you manage infrastructure, software delivery, and those operational tasks. And platform engineering, by doing that, by creating these internal developer portals to put these processes together, this is helping to improve the developer experience. Again, it goes back to how do we deliver changes up to production. But I do want to point out platform engineering is not the only way to improve DevEx. As I talked about, improved, you can improve the documentation. Each individual team can look at how are they writing their code and how are they pushing changes up to production or anything along those lines. So they're part of it, but they're not the only way to improve it. Now, one of the big things that companies will do, or excuse me, platform engineers will focus in on, is building these processes. And they've been given a name. You hear these terms like paved path versus golden paths. So I'm going to put together an analogy, and I hope you bear with me on this one, where we talk about a little bit about a paved path. So what is the difference between the two? And again, I warned you about Simpsons, so we're going to talk a little bit about Simpsons. So there's an old Simpsons episode where Homer Simpson wants to make orange juice, and the way is making orange juice is he's smashing an orange against his head, and he gets interrupted by Troy McClure and Dr. Nick Riviera as they are promoting the juicinator, where they dump in an entire bushel of oranges, and all they get is just one drop. So they've automated the process of getting orange juice, but all they end up with is one drop, was Homer's getting almost a third of a cup. And that's really what a paved path can be, is they're just looking at the existing process and it's just putting some automation in there. Now, a side note, I thought this was really funny when I was putting together this slide deck, so I do have to share this. Um, they actually have made that juicinator. You can go to grocery stores. I'm not going to say it's in every grocery store, but I found pictures where that actually exists today. So, you know, life imitates art, I guess. So Golden Path, what they're doing is it's taking a look at the core rules and the core thing that you're trying to accomplish, but it might be accomplishing it in a different way. And really, they want to accomplish it in a better way to entice people to want to go there and start using it. That way, it's not forced onto someone. It's just, it's like, wow, how do I get some of that action, basically? So thinking back to that orange juice analogy, this belabored point, a better or different way is I just want a cup of OJ. Well, I could go to the store and just buy a carton of orange juice. Why am I making this so difficult? So I want to reinforce this point by putting together an actual real world example. So this takes place when I was working at Farm Credit Services of America, and we had a process to get database changes into production. And we had our standard 4 environments: dev, test, staging, prod. And the idea was, as we make our database changes in development, the developers point their local machines to development, and then they'd update the code, and then they'd merge in the code. And then once that's been merged into main, then they promote it the code to test, and then they move the database changes from dev to test. But there was a small kink in the problem in this whole operation, which was developers were sysadmins in both dev and test in order to support the ability to make changes in both dev and test. Meanwhile, our DBAs, they were the sysadmins in staging and production. And so they're the ones who have that basically have the keys to staging and production. So any process that we put in place will basically change halfway through. The other problem is that development really didn't have a whole lot of data in it. it was really test was where all the good data was. And this is because that's where our business owners and our business analysts and our QA people, that's what they were using for verification. Now, I'm a developer. I'm sure other developers will do that, would naturally do the same thing. They would follow the path of least resistance, and they would basically point their machines up to test. Well, then we started just making changes in test directly. We would skip development altogether. And then we ended up in a situation where we had half-finished changes in test, we had experiments in test, and sometimes test would work, sometimes test wouldn't work because we had code changes that hadn't been pushed up to test. Can be a bit of a mess. And then when we felt like it, we might update development. And that was really basically when we needed to check in our changes. But then when it came time to promote up to staging, we would manually create the scripts. And as you can imagine, because we had half-finished changes in test, we'd had to know the state of all of the differences. Should this go up to staging? Should this not go up to staging? And because we're humans and we're doing this manually, we'd make mistakes. We'd forget something, we'd push something we weren't supposed to go. And as a result, when it came time to deploy to production, the scripts that we had generated for staging were in such a state that we basically had to throw them all out and start all over again. And so when changes went to production, it was a case of, will it work? And I'm not quite sure. Maybe, probably, hopefully. And so I came through and I was like, okay, we need to solve this. So like, let's go ahead and just automate that script creation. That's going to solve all of our problems. But in reality, I ended up in a situation where I was just like Dr. Nick Riviere with the Juicinator, where I kind of actually made the problem worse because there was a lot of nuance that I wasn't picking up on. And I really didn't solve the problem. All I did was I just created a bit of automation around it. So that was what a paved path would be. A golden path is we needed to change how we made our changes completely, our database changes and how we pushed them up there. So the very first thing that we did is we said, okay, we need to put our database schema into version control. That's the big thing that we need to do. The next thing is because the schema is now in version control, we can adopt local database development instead of having the shared development database. That enabled us to have feature branches because now we can make changes to our database schema and our source code in a feature branch. And we could check that in if we so desired, we could have it automatically push up to development. And we could test things, we could verify things. Yep, everything's looking good. But then once we felt confident with the schema change as well as the code change and anything else that we needed to change, we could submit everything in one pull request, get that approved by the appropriate people. So we're no longer doing this approval between test and staging. Now we're doing this before it even gets into main, before we even push the code base into main. Now we can do all of that in one pull request. And then once it gets into main, then we can create a single artifact using the schema and version control, push that up to test, push that same artifact up to staging, and then finally push that same artifact up to production. We accomplished the same goals, which was we needed to make a database change and we needed to get it up to production. We needed to have someone review it. We needed to make sure that it worked with our code base. We accomplished it, but we just did it in a different way. And by doing this, we also made it very enticing because we no longer ended up in a situation where we had to manually do anything. We weren't forgetting things. We weren't pushing up half-finished changes up to staging. A lot of the mistakes we were making kind of just evaporated by adopting this process that teams just go, how can I get in on that action? Like it was very enticing for them. Well, for most of them. Some of them eventually we kind of had to go to the managers and said, okay, you have to change now. You're the last team. So why is this so important? Why now? Well, as we said, developer experience, many people have been doing this on the side for years without calling it DevEx. But there's been a renewed focus on improving the developer experience because people have recognized that, taking forever to onboard a new developer is not a good thing. Taking forever to go to production is not a good thing. But that's been something that's been going on since, DevOps came about really since start of development of software. But what about platform engineering? Why is this suddenly becoming a hot topic? And what I believe is that it's because so many companies today are undergoing digital transformations where they're moving off of their traditional Windows and Linux application hosts into being much more of a hybrid model where now there's a mix of Windows and Linux, but also platform as a service, as well as containerization and Kubernetes. And now people suddenly have to learn a whole lot of new things. If you attended my webinar I would say last month or maybe a couple months ago about Kubernetes, Kubernetes for the rest of us, I talked about everything that you needed to learn just to deploy your very first application, just a very simple container inside of Kubernetes. There's a lot to learn, and you front load a ton of information. And you also have to completely change around how you will develop your code as well as how you host your applications when you start doing things like containers, or you're hosting things on platform as a service. Now you're doing infrastructure as code. There's just so much that has changed. And quite frankly, it's very easy to misconfigure something. So I'm going to tell you a bit of a story. And I'm not going to say anything that isn't in this article, but this came about when I was working at ES&S. So if you are watching this and you're not in America, every jurisdiction is responsible for how you vote. So every county controls how you vote, and then that goes up to the state. So it's very interesting. So in the state of Nebraska, when I want to go in and vote, I go up and I say, okay, my name's Bob Walker, or I give them my legal name, and then I give them my ID. And then they open up this gigantic book that looks at, who is this particular person? And then they say, okay, I see your name, sign here, I'm given a ballot, happy days. Now, most places are not stuck in the 1980s or 70s. They use tablets to check people in. Exact same concept. I go in, give them the ID, they look up my information on a tablet, happy days. Very easy to do. Well, the tablets, they can talk to one another at a polling location, but then they can also go back to a centralized location to see, hey, has that person already come in and gotten their ballot? Now, that centralized location, that's what my team, my group, there's not just a team, but there's actually a whole group of people, several teams, was responsible for. And there had to be a place where that had to connect to. So we were leveraging AWS. We're hosting everything in AWS. And so that had a database of all the voter registration information up there. Now, being good stewards of data, we're like, okay, we need to back up this database in case there's any sort of problem so we can quickly recover it. But then we needed a place to store our database backups. And so we picked S3. That makes a lot of sense. It's a place to store data. But unfortunately, the identity access management for that S3 bucket was misconfigured to allow public access. So this particular company, UpGuard, they're just running scripts looking for public S3 buckets. They found ES&S's public S3 bucket with these database backups, and they were able to download the city of Chicago's voter registration information. There was never a case of the person, like who the person voted for. We don't know that. All we know is that so-and-so came into this polling location and they got a ballot. That's literally all we know. But not a good day. And so, again, it's very easy to misconfigure something when you don't have these guardrails in place. So for digital transformations, to have a successful digital transformation, you have to invest in DevEx and you have to invest in platform engineering. Because if you don't, you're asking people to learn a whole lot and they're going to make mistakes. And it's really easy to misconfigure things. And without the appropriate guardrails in place to not misconfigure something, we've seen what could happen. All right, so how can you avoid pitfalls if you're looking to invest in DevEx and platform engineering? It's important to remember that platform engineering isn't operations 2.0. I can't tell you the number of people I've talked to that said, all I want to tell my developer is like, you build the container, I take care of the rest. Well, if you do something like that, well, congratulations, you just recreated operations where now developers are throwing things over to you versus throwing things over to your web admins or to your DBAs to host. So internal developer platforms, what platform engineers work on, it's not a shared service. And what I mean by shared service, this is something where a developer raises a ticket and then they wait for someone to do work. That's not the case at all. IDPs are a collaborative environment. They are what enable the developers to do work. It creates the processes for repeatable tasks, but the platform engineers are working with all parties involved. So your auditors, your QA people, your support people, your operations, as well as your developers to create the processes and meet the standards. But it's a collaborative environment. The operational work, the act of actually hosting an application, that work is still required. And that's not the purview of platform engineers. You could have a centralized operations team, or you could have people who are focused in on hosting and managing the applications that are embedded within the teams themselves. And they're responsible for making sure the application is up and running. And they're doing all the monitoring and everything along those lines. It's important to treat your IDPs like it's a product. And what that means is your developers and operations and everybody else, they're the customers. And so those platform engineers, they're making sure that they're building processes that meet the goals of the developers and operations. They're not just making processes to make processes. Back to the whole paved path versus golden path. They should be building golden paths to make it easy for people to adopt, and it solves a lot of the problems. Which brings me to my next point, which is you should build golden paths, not paved paths. You should make it easier, reduce the cognitive load. You shouldn't just be automating something to automate something. Really make sure that you understand the core business rules and you're meeting the business rules and you're making it easy to leverage those particular processes. Your IDPs, they should be open source. You should allow your developers and operations to contribute to it. It shouldn't just be the purview of platform engineers and they're the only ones that can make it. And what I mean by open source, that doesn't mean you need to use an open source product. So probably the most popular IDP software that's out there right now is Backstage, and Backstage does work. I know a lot of companies who have been successful in using Backstage, or I've heard about a number of companies who are successful in using Backstage. But I've also heard about a number of companies who have had a bad experience using Backstage because it is so cumbersome to work on. So it doesn't mean you have to use their product. Really what I'm talking about is the processes themselves. Like if you've built out, say, Terraform providers using, say, Octopus deploy, that should be open source. You should have contributor guidelines on how to do that. Have really good documentation to make sure that's always up to date. Help contributors feel empowered to improve the overall process, which makes them feel empowered to improve their developer experience. They should be easier to use. I've been using this term a lot internally. The higher the friction, the slower the adoption. But what that means is that if you have made it so hard to adopt something, and there's so many different steps to do a particular task or to start using a process or using a CI/CD pipeline, no one's going to want to use it because they're really, really busy. I always laughed because I worked with someone who would come up with this process and they say, you can adopt this process in 3 easy steps, but then every step had like 17 sub steps that you had to go through and it took you days to adopt. It's like that wasn't really easy. That was, you know, when I'm on step 3.15, I know there's a problem. It's also important to note that IDPs, they can't solve company cultural problems. If you are uttering the phrase or you've heard someone utter the phrase to you, no tool on earth can fix I don't trust developers, there's nothing that we can really do. There's not a tool out there. This is a company culture problem. You need to start working with people, or you need to find a way to break down those silos, because this isn't a way to just basically say, this is the process, you have to use it, too bad if you don't like it. That's never going to work. All right. Well, let's talk a little bit about measuring success once you start adopting platform engineering and start really focusing in on developer experience. It is important to measure to know you have that impact, to know if you're doing something correctly. I just think, sorry, back to The Simpsons. If you think back to how do you know if you're cool? Well, someone has to tell you, right? But really, if you don't measure what you're doing, you have no idea if it's an improvement or if it became a detriment. And you don't want something like that. You want to make sure that yes, this I am improving. And if you do see a detriment when you see the measurement start going the wrong way, like okay, we tried something. Well, it sounds like we need to change it or revert back. Again, there are measurements that are out there, that people have been talking about, like the F5 contract, the time to first commit, as well as the door metrics that are available to you. Now, I will say the door metrics are good and they're a good starting point, but they're not the end all be all. Now, internally at Octopus Deploy, we're measuring, we have other measurements for success. And so I'm going to walk you through some of these. I'm actually going to show you some diagrams that we use that are a little out of date. I think they're a couple months old, but you should hopefully get the general idea as to what's going on. And so we're focused in primarily on the PR build duration, the lead time to changes, so that is a door metric, batch sizes, mean time to recovery, but we have an interesting way of doing that. So I want to get into that in a little bit. And then the high severity defect escape rate. That's a word salad. Essentially what that means is that, as we add new features and functionality into any tool as developers, there's always going to be the unknown use cases that you just hadn't planned for and where defect occurs, or something that you thought was an edge case actually is a lot more common than you originally thought. And so because of this, you might end up in a situation where you have bugs. And bugs are natural with writing software. But some bugs are annoyances where, okay, something appears on the screen for a brief second, disappears, and then the actual screen appears. That's an annoyance. But if it doesn't work, well, that's a show-stopping bug. And so we're focused really on that. What has caused a show-stopping bug? If that does happen, how do we prevent that from happening again? Okay, so let's talk a little bit about a PR build duration. So it's pretty self-explanatory. How long does it take for a PR build to complete? So our current SLI is we want to be under 75 minutes per PR build. And that sounds like a lot. Well, first, Octopus Deploy is a huge code base, but we also have a lot of tests and integration tests that need to run to make sure that we're checking in quality code, especially for a PR request. And right now, it looks like we're hovering around, like we're maxing out around 50 minutes, which is pretty good. But our goal, because it's important to have goals, is 30 minutes, is to get this down. But what's important about this is by measuring this, we can see situations where, for whatever reason, the PR build duration, it jumped up for a couple of commits. And then it went back down. And we kind of see these peaks and valleys. And so then it's really a question of, okay, why does this continue to happen? So it's a good indication by measuring, saying, okay, something's not working right. Something changed in the code base. Has something changed in our process? Is something going on with our platform? What's going on here? It's a good way to indicate that there's a problem. And then our long-term goal is, can we get down to less than 20 minutes? Lead time to changes, that's a pretty standard metric, which is how long does it take for a commit to get from basically check-in up to production. And we can see that our goal is 1 day, but our monthly average is about 5 days and 21 hours. But we can see a lot of that was really dragged up by one particular release, 2024.26041. What was going on with that? And then we had another one that was pretty big, 2024.26963. So when we see a massive lead time to change for something like that, raises a lot of questions. Again, this is why measuring is so important, because you can identify those outliers. But it's also important to measure other things. So we're looking at batch sizes, and we can see that the the two most recent releases that had the biggest lead time to changes also had the biggest batch size. That's actually not super surprising. Why did that happen? So there were a lot of changes that were made in that particular release. So lots of questions would naturally be raised by it. Why was that? Why do we have such a large batch size for that particular release? But again, measuring helps you identify some of these things. Our mean time to recovery is interesting because as a software vendor, we have to push our code out for our customers to use. And sometimes it takes a while for our customers to hit a particular defect. Uh, sometimes it's the sun and the moon and the stars to actually align. And so it might take a while for us to hear about it or for it to be detected. And then it became a case of, okay, once we detect it, then how long it takes to fix it. So it's a question of, again, going back to the measuring, okay, why did it take so long to detect an issue? Not saying it's good or bad. Maybe it just took so long for that edge case to appear. Or if it happened right away, it's like, okay, how did we miss that in our testing? Again, measuring can help drive some of these conversations. So platform engineers, this is another part of their job. As outside from building those IDPs, it's gathering and visualizing this data. This data that I'm showing you, this is coming from a lot of different sources. We're talking Team City, Octopus Deploy itself, because we use Octopus Deploy to deploy Octopus Deploy in a weird snake eating the tail type of scenario. And then it's also coming from GitHub issues. GitHub is along with that, any number of those different things. So it's about ingesting all of that data and then visualizing it in an appropriate way, and also determining what's the appropriate things to show and to measure. Okay, so we got a couple of resources available for you in case you're interested in learning a bit more about platform engineering and developer experience. So developerexperience.io, great website. I also have to plug Octopus Deploy. So we have the DevOps microsite that's out there, and there's a big section that's devoted in on platform engineering. We have a couple of blog posts where we talk a little bit about paved paths versus golden paths, as well as why you have platform engineering. I also linked to Microsoft in terms of platform engineering. What is platform engineering? Anything along those lines. And then a number of those other things, such as developer experience. And then I also linked to the GitHub blog. So if you want, take a screenshot and hopefully get all that particularly good information. There's a lot of resources that are available to you, but I just kind of linked to some of the ones that I was using as I was putting together this particular slide deck. And so that's really it for me. Just a hair under 50 minutes for this particular session.